Hello friends, I am Dr. Sudhan Sharma from School of Computer and Information Sciences, Indira Gandhi National Open University. In our previous session, we learned how to solve linear inequalities in single variable. In this session, we are going to learn about solving linear inequalities in two variables. The objectives of today's sessions are after going through this session, you will be able to graph the solutions set of linear inequality in two variables. Graph solution set of system of simultaneous inequalities in two variables, and find solution set of quadratic and nonlinear inequalities. We learned in our previous session that there are equations wherein the left hand side is equal to right hand side, and they are the equality part. That's why they are called equations. Apart from this, if the equal to sign is being replaced by greater than, less than, greater than equal to, less than equal to, then the equations get transformed into inequalities. The inequalities might be in the terms of a single variable or in the terms of the double variable. In this session, we are going to explore firstly the inequalities in two variables. So, a linear inequality in two variable is an expression that can be put into the form ax plus by less than c, or ax plus by greater than c, ax plus by less than equal to c, or ax plus by greater than equal to c, where a, b and c are the real numbers, and where a and b, that is the coefficient of x and y, both are not 0. Because if the coefficients of x and y become 0, then the equation will be transformed into an inequality of single variable. Apart from this, the inequality symbol can vary from greater than, less than, greater than equal to, less than equal to. There are some examples given over here wherein we are giving that x plus 3y is less than 6, or y minus x is greater than 1, or x plus 2y is greater than equal to 1, and 2x plus 3y less than equal to 6. These are some of the examples of the linear inequalities in two variables x and y. We are here to learn how to graph the solution of linear inequalities in two variables. In this section, we are going to learn how to identify that which region represents the solution of the inequality. So, the solution set of a linear inequality in two variables is actually a section of a coordinate plane, because we are having two variables x and y. If we are having a single variable x, then obviously it will be a one-dimensional representation and the solution will be represented only onto a line. But in this case, we are having two variables x and y, so the solution set will be represented by a plane. Now, it is very important to understand about how to represent the boundary of the section. The boundary of the section can be either in the form of a solid line or in the form of a dotted line. The solid line will be considered when the inequation, rather I should say, that is the inequality, is having the symbol less than equal to or greater than equal to. That is, the equal to part is existing. In that case, the solution set includes the lines that partitions the plane. So that's why the solid line is considered for the representation. But when the inequality is having the symbol less than or greater than, that means there is no part of the equality. That means it is not representing less than equal to or greater than equal to. Then the line is supposed to be represented in the form of a dotted format. So that means the line segment is not included into the solution section. A solid line represents that the points lying on the line are also included into the solution of the inequality. So over here we had shown you a graph of the equation 2x plus 3y is equal to 6. In order to find the graph, firstly we are supposed to represent we will discuss in the upcoming slides, wherein the steps are being literally explained how to draw the graph. So we learned what do the boundary represent, and there are different type of boundaries. A boundary can be a solid line wherein the inequality is less than equal to or greater than equal to, and the boundary can be a dotted line wherein the inequality is following the symbol less than or greater than. That means the points lying on the boundary are not included to the solution. In order to understand this drawing of the graph in a better manner, let's consider an illustration. Over here in the illustration, we are supposed to represent graphically the solution set of the equation 2x plus 3y greater than equal to 6. Now, in order to draw the graph of the solution for this inequality, the boundary of the graph is to be plotted, for which we need to calculate the x-intercept and the y-intercept. Now, in order to obtain the x-intercept, firstly put y is equal to 0 in this equation, and substituting y is equal to 0 in this equation, you will get 2x greater than equal to 6. That is, x is greater than equal to 3. So, the one of the intercept is 3, and in order to find the y-intercept, you are supposed to substitute x is equal to 0 in this equation, 2x plus 3y greater than equal to 6. Now, substituting x is equal to 0, you will find that the y-intercept turns out to be 2. So, over here we are having a y-intercept that is 2, y-intercept that is 2, and x-intercept that turns out to be 3. We draw a line that connects these 2 points, 2 and 3. And now, since we are having the equation 2x plus 3y greater than equal to 6, so the region lying on the right hand side, all the points on the right hand side of this line will be representing the solution. Now, actually this line which we had drawn from the intercept to y-intercept 2 and x-intercept 3 is actually the boundary which splits the coordinate plane into 2 sections or the regions. And that means there are 2 regions, region below the line and region above the line. Now, in order to find that whether which point satisfies the equation, the solution set lies in which region. So, it is convenient to substitute the points. Likewise, over here we can substitute the point origin in this equation, that is 2x plus 3y equal to 6. Substituting origin, that is 0 0 in the equation 2x plus 3y greater than equal to 6, you will be getting 2 to 0 plus 3 into 0 greater than equal to 6, which is 5 greater than equal to 6, and which is false. That means origin does not satisfy this inequality. So, that means the solution set will be lying on the other side of the origin. Apart from this, we can also verify any point which is lying on the left hand side of the line, be it say point 1 1. Now, again substituting this point 1 1 in the equation 2x plus 3y greater than equal to 6, you will get 2 into 1 plus 3 into 1 and greater than equal to 6, and this is 2 plus 3 greater than equal to 6, which turns out to be 5 greater than equal to 6, and again this is false. So, that means point 1 1 also won't represent the solution set of the equation. So, that means all the points lying on the right hand side of the line, that is this shaded region actually represents the solution set of the line, all the points lying on the right hand side of this boundary. Again, one more observation is there, that the boundary which is shown over here is a solid line. Why it is a solid line? Because the inequality is carrying the symbol less than equal to, greater than equal to. Because greater than equal to sign is there, so that means greater is there and equal to part is there. So, all the points lying on the boundary are also included into the solution set. That's why the boundary line is represented by a solid line and not by a dotted line. There is a standard procedure to graph the solution set of the linear inequalities in 2 variables. The step 1 says that replace the inequality with the equal sign. So, firstly replace the inequality whatever 2x plus 3y greater than equal to 6. In order to solve this, firstly you replace by an equal sign. A resulting solution set, the resulting equation is actually representing the boundary for the solution set. If the equation is carrying greater than equal to, then it will be carrying a boundary with a solid line, because the boundary is included in the solution set. But if the equation is say 2x plus 3y greater than 6, there is no equal to part, then in that case use broken line to draw the graph of the boundary, as the solution is not included, as the points lying on the boundary are not included in the solution set. Now, after that there is a final step. Choose any convenient point not on the boundary and substitute the coordinates into the original inequality. Likewise, in the illustration, we substituted 0 0 and 1 1, and we verified that these 2 points are not satisfying the inequality 2x plus 3y greater than equal to 6. So that's why we identified that the solution is lying on the other side of the line. That means we need to find that the resulting statement is true or not, because by substituting 0 0 or 1 1, we find that the resulting statement is false and the solution lies on the opposite side of the boundary. So I hope you learned about that what is the procedure to graph the solution set of the linear inequalities in two variables, and we illustrated with the help of example also. Let's solve some more examples. Likewise, over here we are given an inequality y less than 2x minus 3. Now again, to solve this, let's follow the step. The first step is to replace it with the equal sign. So y is equal to 2x minus 3 is now the equation, and we determine the intercepts. Why we need to determine the intercepts? Because we need to find the points where the line, the boundary line, intersects with the x axis and the y axis. Now substituting x is equal to 0, we get the y-intercept as minus 3. So y as minus 3 is the one of the intercept. Substituting y is equal to 0, you will get that x-intercept is 3 by 2. So 3 by 2 is the x-intercept, and because the inequality is less than, so obviously the line should not be, boundary line should not be a solid line, it should be a dotted line connecting the intercepts minus 3 and 3 by 2. Now we are supposed to verify that which coordinate systems satisfies the equation. Now firstly, let's substitute the origin point, that is 0 0, into the equation y less than 2x minus 3. Substituting y is equal to 0 and x is equal to 0 in this equation, you will get 0 less than minus 3. This statement is false. So origin is not satisfying the equation. So the solution set is supposed to lie on the opposite side of the origin. So that's why the solution set is lying on this side of the boundary line. We can also substitute 0.11 over here. You can see from the graph also that 0.11 is also not satisfying the points lying on the boundary. Substituting 1 and 1 into the equation y less than 2x minus 3, y is equal to 1 and x is equal to 1, you will see that 1, 2 minus 3, that is 1 is less than minus 1, which is again a false statement. So 1 1 is also not satisfying the equation. So that means the solution set is lying on the opposite side. So that means this is how we are supposed to graph the solution set of a linear inequality. Now many a times we are having composite system of inequalities and we need to graph the solution of composite system of inequalities. Likewise over here, a system of linear inequality in two variables, two equations are given over here, 2x plus 3y less than equal to 6 and x plus 2y greater than equal to 4. Now again the same procedure will be followed. Firstly, we need to find the intercepts of the two equations and we draw the boundary line. Second observation, the inequality is carrying the symbol less than equal to and greater than equal to. Since equal sign exists over here, so the boundary region will be represented by the solid line and not by the dotted line. So in order to draw the boundary for first equation, say 3x plus 2y less than equal to 6, we can determine the x-intercept and the y-intercept. Substituting y is equal to 0, you will, and rearranging the equation, you will get that the x-intercept turns out to be 6 by 3, that is equal to 2. So 2 is the x-intercept for this equation, 3x plus 2y. Substituting x is equal to 0 in this equation and solving it for y, you will find substituting y is equal to 0, you will get x is equal to 2. So x is equal to 2 is the x-intercept, and thereafter substituting x is equal to 0, you will get y is equal to 3. Y is equal to 3 is the y-intercept for the equation 3x plus 2y equal to 6. Similarly, you can find the x-intercept and y-intercept for the equation. Substituting y is equal to 0, you will get x is equal to 4. X is equal to 4 as one of the intercept, and thereafter substituting x is equal to 0, you will find that y is equal to 2 is the other intercept. So we will get two lines, one line connecting point 3 and point 2, and other line connecting point 2 and point 4. Now, because one line we are having the inequality less than equal to, that is 3x plus 2y less than equal to. So 3x plus 2y equation, the solution will be lying on the left hand side, and to x plus 2y greater than equal to, the solution set will be lying on the right hand side. So the intersection of the two is represented by this region. So this region represents the solution. We can also verify by substituting some of the points, say origin, into the equation. So substituting origin, that is 0 0 into 3x plus 2y less than equal to 6, you will get 3 into 0 plus 2 into y less than equal to 6, 2 into 0 less than equal to 6, which is 0 is less than equal to 6 is true. So the solution set will be covering origin if we shade the other line, that is 2x plus 3y, because the solution is lying on this side. So this will be covering 0, but we need the solution, we need the region wherein both sections, both equations are satisfied. So if we substitute 0 0 into the other equation, we find that it is not satisfied. So substituting 0 0 in x plus 2y greater than equal to 4, so 0 plus 2 into 0 is greater than equal to 4, that is 0 is greater than equal to 4, which is false. So we need to find the region which is the solution for, which is satisfied by both equation. That region will be a common region, and this region will be given by this common shaded region. So I hope you understood how to find the solution of the linear inequalities in two variables when we are having a system of linear inequalities, that is more than one inequality exists. Now, many times we are also having quadratic and other non-linear inequalities, and we are in this section we are going to discuss about quadratic inequalities. We already learned about how to solve the quadratic equation, that is ax square plus bx plus c equal to 0. But if this equal to sign is replaced either by greater than or less than or greater than equal to or less than equal to, then the inequality get transformed into the quadratic inequality. So this is one of the example of the quadratic inequality, and now we will learn how to determine the solution set of the quadratic inequalities. So there is a proper procedure to solve the quadratic inequalities. The steps are listed over here. We will learn how to apply these steps to solve the quadratic inequalities just by an example. So the step 1 says that write the inequality in such a way that one side of the inequality is 0. Step 2, write the quadratic expression as product of linear factors. Step 3 says replace the inequality sign by the equality sign, as we did earlier also, and solve the resulting equation to obtain the critical numbers. And in step 4, plot the critical numbers on the number line and name the different regions as 1, 2, 3 or so on. And step 5, take a value from each region and check if the inequality is satisfied for that value. If it doesn't, include the region into the solution set, otherwise reject the region. Step 6 says that check each of the critical region to see if it is a part of the solution, and finally write the solution set. Now it appears to be quite cumbersome, but it is very simple, and let's learn it by solving a numerical. Over here we are given a quadratic inequality x square minus 5x minus 6 less than equal to 0. When we were understanding about the quadratic equations, we learned how to solve the quadratic equation, and one of the mechanisms was to factorize, wherein we need to find the two numbers that multiply to the constant value, that is minus 6 over here in this case, and add up to minus 5, which is the coefficient of the linear term x, which is minus 5 in this case. So the two numbers are 6 and 1, because minus 6 into 1 turns out to be minus 6, but minus 6 plus 1 turns out to be minus 5. So by factorizing this equation, we can write this equation x square plus 5x minus 6, x square minus 5x minus 6 as x square minus 6x plus x minus 6, because minus 6x plus x turns out to be minus 5x only. So rearranging this equation, you will find that the two solutions are x is equal to 6 and x is equal to minus 1. So these points are listed over here onto the line. So 6 and minus 1, and because there are 2 points, the entire line gets segmented into 3 sections, 1, 2 and 3. Now we test for each region that wherein our solution is actually lying. In order to find that in which region the solution lies, we are supposed to substitute the values for respective regions. Likewise over here, let's put a value which is less than minus 1. Say we substitute the value minus 2. Now substituting the value minus 2 in your factorized equation, that is x minus 6 into x plus 1, you will find that minus 2 minus 6 and minus 2 plus 1. So that is minus 8 into minus 1, that turns out to be 8, and which is not less than 0. Because the inequality which is given to us is x square minus 5x minus 6 turns out to be 0. That is x minus 6 into x plus 1 should be less than 0. And we got it. We got this value 8 by substituting the value minus 2 which lies in the region 1. Now that means the solution set is not included in region 1. Let's verify it for region 2. Now in the region 2 is the region which is lying in between the points minus 1 and 6. So we are having the inequality x square minus 5x minus 6 less than 0, which is factorized to x minus 6 into x plus 1 less than 0. Now region 2, say we take the point 0. So substituting 0 minus 6 and 0 plus 1. So this turns out to be minus 6 into 1. So yes, minus 6 is less than 0, minus 6 is less than 0. So in this region, the inequality is true. That's why the solution is lying in region 2. Similarly, we can verify for point 3. If we substitute any point, say we substitute point 7, which is a point from region 3 into the inequality, that is x minus 6 into x plus 1 less than 0, then we will get 7 minus 6, substituting x is equal to 7. 7 minus 6, 7 plus 1. 7 minus 6 is 1 and 7 plus 1 is 8. And that means 8 is not less than 0. That means solution set is not lying in region 3 also. So solution set is not lying in region 1, not lying in region 3, but it is only lying in region 2. That's how we can graph the solution of a quadratic inequality. It is very simple. Just solve the quadratic equation and by the method of factorization, find the roots and plot the roots, and then find that which region satisfies the solutions. We had already discussed about that how to find the points which are satisfying the respective regions, and over here we had substituted x equal to minus 2, and we find that the inequality is not satisfied. Thereafter, we had used the point x equal to 0, and we find that region 2 is the solution set because over here this inequality is satisfied. In region 3, by substituting x equal to 7, we find that again the inequality is not satisfied. So the solution is only represented by the region 2, and we can represent the solution set as x, wherein the x lies in the value of x lies in the region minus 1 to 6. So this is how we solve the quadratic inequalities. But there is a caution that sometimes the students attempt to solve the quadratic inequality as if it is a quadratic equation. And over here, say we said that x plus 1, x minus 1 minus 6 is less than 0. So this should be less than 0 and this should also be less than 0, which is not the correct way and should never be used. So it is advised to properly follow the steps which are illustrated over here in this session and also discussed with the help of several examples. So I expect you to solve more and more numericals which are given into your self-learning material so as to have better understanding of the concept of the inequalities. Thank you.